There are two ways to name alcohols, the so-called common names and the systematic IUPAC or IUPAC names. Let's take a quick look at the common names. It's simple. Simplest alcohol there is, methanol. The common name is methyl alcohol. You simply name the alkyl group and then as a separate word say alcohol. This is the ethyl group, so it's ethyl alcohol. These four carbons are the isobutyl group. And so on and so forth. So just review the names of the alkyl groups that you've learned so that you're ready to name whatever comes along in terms of common names. Name the alkyl group and alcohol. There are a couple of ringers that would be worth mentioning. When there are two hydroxyl groups on a two-carbon chain, it's called ethylene glycol. Obviously this isn't ethylene, but it's made from ethylene. This is an important compound industrially, and it's an important compound to you guys because it's the key constituent in antifreeze that keeps our radiators from freezing up in the winter. Or a close cousin is used, compound that has 3 carbons, propylene glycol, also made from propylene. So that's the common nomenclature system. It's simple. Remember a couple of special cases, but mostly simply name the alkyl group we're talking about and say alcohol as a second word. That's the common nomenclature. The systematic nomenclature follows the set of instructions that we've learned for all of the compounds that have functional groups. Take a look. The first step is always to find the highest priority functional group. And then identify the longest chain that contains that functional group. There may be longer chains, but a chain has to contain the highest priority functional group. Then write the alkane name of the longest chain. Change the name to designate the functional groups present. Might be one or more than one. The highest priority group is placed last in that list of functional groups if there's more than one. Name all of the substituents. All these substituent names go in front, and we place all the substituents in alphabetical order. Number the chain. Beginning at the end that is closest to the highest priority functional group. Place numbers in front of the functional groups and substituents to show their location. And finally, add any needed stereochemical designations. At the very front of the name. This would be designations for chirality centers and for EC alkene stereochemistry. So there you have it. It's a set of rules that we must follow. If you systematically follow this set of rules, you can name anything. Let's look at a few examples. Step one is to identify the highest priority functional group. Well, that would be the OH. Remember, halogen has no priority at all. It's simply named as a substituent. And then we need to locate the longest chain that contains that functional group. It might help to just put dots at every single carbon so you don't get confused about which ones are which. And I took a turn down here rather than going straight because this is a 2-carbon chain and this is a 3-carbon chain. And now we see that this has 7 carbons in the chain, and it's a heptane. And then we need to change that name to show that that functional group is present. So we take the E off the alkane name and replace it with OL. The OL is the alcohol designator. Now we need to name the substituents and place them out in front. Check it out. We have a chloro substituent here, and we have an ethyl substituent here. So this is C, this is E. We'll put the chloro ahead of the ethyl. I'm keeping these separate for now for a reason. You'll see that in a second. So these are substituents in alphabetical order. And now we need to say where everything is. The alcohol group, the ethyl group, the chloro group. So we need to number this chain and number it from the end that's closest to that functional group. So the hydroxyl group, the alcohol, is on the 3rd carbon. We need to say this is 3-heptanol. And the ethyl group is on the 4th carbon. We need to say this is 4-ethyl. And the chloro group is on the 7th carbon. And now we have the name. It's 7-chloro, 4-ethyl, 3-heptanol. I can also tell you that in some cases this 3 designator is placed just in front of the OL, the hydroxyl designator. So either location is acceptable in this name. And then finally, what if this molecule had stereochemistry? So let's change this to show that it is a hydroxyl group is toward us and the hydrogen is back. And now we use our Kahn-Ingold Prelog priority to determine that the hydroxyl group is number 1, this carbon is 2, this carbon is 3, the lowest priority group is back, we find ourselves going clockwise. This is the R stereochemistry, which is put in parentheses in front of everything else. And now you have it. What would be different if this were an alkene? Take a look. Now we would be looking for the longest chain that contains the highest priority functional group and the others. This is not the longest chain, but it's the longest chain that contains the alkene and the hydroxyl group. So now we're going to call it a 1, 2, 3, 4, 5. This is a pentane. And we're going to alter that name to show the presence of the functional groups, placing the highest priority functional group, hydroxyl, last. So this is a pentenol. We've taken that ANE and changed it to an ENE for the pentane. And we've taken the O and changed it to an OL for the alcohol. And I've left the space because we're going to have to put the number designator for the alcohol right in front of the OL in this case. And so our next step is to name the substituents, and we have one. This is the N-propyl group. Because it's got its own dash, we have to put a parenthesis in front of this thing. And now we'll need to number the chain, which we can do from the end that's closest to the highest priority functional group, 1, 2, 3, 1, 2, 3. They're identical, but this is closer to the next one. So we're going to call this 1, 2, 3, 4, 5. And we see that we have a 2 N-propyl group. We have the alkene at the 1, 2 carbon. That's 1 pentene, 3 ol. And yes, we need a stereochemical designator. This is still R. So systematically, we've figured out the whole thing. I want to look at another example. It shows you something about rings. Now we've got a ring attached to this chain. The rule is still the same. Find the longest chain or alkyl group that contains the highest priority functional group. Of course, we identify at the beginning the highest priority functional group. There's only one. And find the longest chain that contains it. Then we'll name that name according to the alkane that has 4 carbons, butane, and change that name to show that it has a hydroxyl group, that it's an alcohol. And so we have butane changed to butanol. And we'll name the substituents. There's only one. This is the cyclopentyl group. There are 5 carbons. We'll number the chain, starting from the end that's closest to the highest priority functional group. We'll put the number substituents to show where these guys are. This is on the first carbon, and the OH is on the second carbon. And this is still the R stereochemistry. We'll put that out in front. Let's look at another ring. Now we have the hydroxyl group attached directly to the ring, so we're going to call this a cyclopentane changed to cyclopentanol. We'll replace the E on the end with OL. There are two substituents, methyl groups. If there are two of the same thing, we will say dimethyl rather than naming them twice. And while you might think that we would put a 1 in front of here to show where the hydroxyl group is, when it's a ring, that 1 is understood. So this doesn't need a number designation, and we can move this dimethyl to be part of that same name. Of course, we need to say where those methyl groups are, and they're both on the third carbon. We will number in the direction, starting with the highest priority functional group, that gets to the substituents quicker. Let's call the OH on 1, 2, 3, 4, and 5. And in this case, we see that we have 3,3, dimethyl cyclopentanol. Now, this is not a chirality center where the methyl groups are, but this one is where the hydroxyl group is. And when we look at this numbering, of course, oxygen is 1, hydrogen is 4. These two are identical. This one is higher priority than that one. So this will be 2, and this will be 3. The lowest priority group is away from us, and we find ourselves going 1 to 2 to 3 counterclockwise. This is S. And we're done. So there you have it, a few examples of using systematic nomenclature to name alcohols. Let's take a quick look at phenols. Phenols are 6-membered ring compounds that have a hydroxyl group attached directly to the ring. And that ring is very special. It has alternating double and single bonds. And you'll notice right away that there are 2 equivalent resonance structures. Our arrow pushing, we could picture this pair of pi electrons moving to here. This pair has to move to here then, and this pair has to move to here. This movement takes place all at once to generate a second resonance structure that is fully equivalent to the first. There's no distinguishing the two. And furthermore, there aren't 2. There really are only 1. So a better way to write phenol, just generally, would be to not show the single and double bonds, but we just write a circle. And using a circle like this reminds us that we don't have alternating single double bonds, but there's a single structure, and this cyclic 6-membered ring, alternating single double bond single structure, is very special. So the compounds don't behave like alcohols very much, and they have their own special names. So the simplest one is phenol. We'll learn more about naming when we take up aromatic compounds, but for now, simply know that You can name substituents using the same numbering system that we've already talked about for cyclic alcohols. And so if you have a substituent, let's say on this carbon, we would number starting with the OH in a direction that gives us the lowest number to get to bromine, and call this 3-bromophenol. If we have substituents here and here, the lowest number first as we go around the ring to find substituents. And this is called, in alphabetical order, 5-bromo, 2-methyl, phenol. So we're modifying the systematic nomenclature of alcohols to the extent that we call them all a special name, phenol, and then we'll use the similar rules. Again, we're using no number for the OH because it's always at the first carbon. And there you have it. Systematic nomenclature lets us name any alcohols and phenols easily and unequivocally.